Hello everyone and welcome to the first week. We will start with chapter 1, which is about describing data, graphical and basic tables. So what's data? Data is what we have to make analysis. And to conduct this analysis, we use statistics. Actually, statistics has become very popular these days. And now there are advanced branches of statistics like data science, machine learning, algorithmic trading, and things like that. Statistics is the foundation for those kinds of advanced positions. So what's statistics? Statistics is a tool to help process, summarize, analyze, and interpret the data. So here are some basic definitions. Population versus a sample. So population, what's the population? Population is the collection of all items of interest. And we denote the population by the cap, big cap N. Sample is a subset of the population. And we show the sample size by the small letter n. A parameter is a characteristic of a population. This is actually what we are trying to estimate. A statistic is a characteristic of the sample. So we use the statistic to find information about parameters. So what we do is we use statistics to find information about parameters. We don't see the parameters, but we see the statistic. And we try to get the best estimate of the parameter. So here's another example, population versus sample. Population is, let's say, the entire student population of the university. That's population. So it's like everybody involved as a student at the university. Sample, maybe just a few students enrolled in my class. That will be sample. So to conduct sample, we try to make it as random as possible. And the best way to do this is to conduct simple random sampling. In a simple random sampling, the chances are equal that you can choose any member of the population. And it has to be perfectly random. Now, one way to achieve that random sampling is to conduct systematic sampling. So you rank the, let's say, population according to a specific parameter, and then from that population you choose people randomly using a specific formula. So say you choose the first one, and then you choose 10, you choose 20, 30. So each time you choose someone else differently in a predefined algorithm, that is systematic sampling. So we have two types of statistics. For this course, we will start with descriptive statistics. Descriptive statistics is basics like graphics and numbers that summarize and process data. But for the project, we will do inferential statistics. Inferential statistics means like conducting hypothesis testing, making predictions, forecasting future. That is called inferential statistics. So for descriptive statistics, first we have to find data, and if it doesn't exist, then we have to collect the data, maybe using a survey. And then we present the data using tables and graphs. And we summarize the data using statistics, such as sample mean, sample standard deviation, properties of the data. For inferential statistics, we do estimation. For example, let's say you want to estimate the IQ level of the students, but then you choose a few members. So using those few members, you try to get an overall estimate. So that's actually estimation, inferential statistics. Or let's say in the elections, what they do is they ask maybe few thousand people on which party they're going to vote for, and from that sample we try to estimate who will win the election. That's actually called inferential statistics. So for any kind of statistics, we need data. So data is the foundation of statistics. And data can be continuous or it can be discrete. So either if it is numerical, then it can be either discrete or it can be continuous. Now, discrete means something like a fixed, like number, integer number, number of children, number of students. It's a number where if you make it fraction, it doesn't make any sense. So for example, you might have 2 sisters and 1 brother. We don't have like half sister, quarter brother. Now continuous is another type of numerical data. For example, time. Time is a flow numerical variable that's continuous. Category. So this is actually pretty easy. It's not numerical, it's just categorical data. For example, the best example is the gender. Someone can be female or male. So there are 2 categories. It can be colors. It can be, you can also create your own categories. For example, in marital status, we have like single, married, divorced, and maybe a few other options. That's called marital status as a categorical variable. So here's a class activity. We will conduct the class activities during the lecture time, so I'll skip that one. So graphical presentation of the data for categorical variables. We can use frequency distribution, cross table, bar chart, pie chart, and Pareto diagram. For numerical variables, we can do a line chart, frequency distribution, histogram, scatter plot, stem and leaf. Now stem and leaf is very old style, so we will not see that one, but we will see different other types of graphs, especially scatter plot. So for categorical data, we can tabulate the data. Like tabulate means like using tables. Tabulate the data by means of frequency distribution table. And we can also simply graph the data using bar chart, pie chart, and also Pareto. So here's a frequency distribution table. In this table, we have the hospital patients by unit. Actually, that's kind of old data right now. The largest number of hospital patients is because of COVID-19. Actually, no, there are no surgeries anymore. So, as an example, let's just continue with the example. As you see, the number of patients from surgery is 4,630, and we have cardiac care, emergency, intensive care, and maternity. And this is a total number. If you divide each number of patients with the total, and you will get a percentage. So for example, 1052 divided by 8819, you get 11.93%. So we calculate those percentages. So if you calculate them, you can have Damn it, skip that one. Anyways, we also have a cross table example, and this is a different example about investors. We have investor A, investor B, investor C. They invest in stocks, bonds, cash. So it's actually categorical A, B, C category. So it's like categorical data. And using this categorical data, you can create a cross table. And similarly, from this cross table, what we can do is we can visualize their investment choice by using a horizontal bar chart. For example, let's look at investor B. That person has more than 50,000 in stocks, 43,000 in bonds, and maybe 20,000 in cash. And we can also visualize the same example using a stacked bar chart. Again, investor B has the highest amount invested in the green. The green is stocks, and next is bonds, and next is cash. Another example, this time we have both the table. This is there are 4 quarters and 3 territories, so that makes about 12. So it's actually 3 by 4 cross table. And from the same cross table, we can also visualize the graphics. And if you have a time on one hand, the time is usually on the x-axis. So first quarter, second, third, and fourth quarter. So this is a bar chart example. Actually, this is the same example that we had. It's about hospital patients. And as you can see, cardiac care has about 1,052 patients, emergency is about 2,245 patients, and the largest is surgery. Surgery is about 4,630 patients. We can also visualize the same graph using a pie chart. So this is an example of a pie chart which you can visualize, and the pie chart is actually shows us that the surgery is 53%, emergency is 25%, cardiac care is about 12%, and we also have maternity and intensive care. So Pareto chart is the last type of categorical visualization. Pareto chart is actually 2 charts in one chart. We have a bar chart where we show categories. We also have a cumulative polygon that shows the same in the Pareto diagram. So let's see an example. So in a factory, you look at the defective items and you want to figure out why they are defective. For example, for this factory, the biggest factor is poor alignment. That's 233 defects out of 400 is because of poor alignment. And after the poor alignment, we had the paint flow and others are coming. So what you do is you put them in the order of highest frequency. So poor alignment has the highest percentage frequency, and that's followed by paint flow and bad welding, and others keep going on. So the first step is to sort by the defect cause, why they are defective, starting from the highest and go to the lowest. And then next step, you also need to determine the percentage in each category. In the class time, actually we will do an example on Excel, and I will show you how we draw those graphs in Excel file. But this is actually the ultimate result. At the end, you see that 55% is because of poor alignment, 20% paint flow and bad welding, and others are coming after that. So this is the bar part. And then we also have a line. So the line will show us on the right side, cumulative percentage. So the axis of this line is on the right side. The axis of the bars will be on the left side. We will do an example of this Pareto diagram in the class. Now for time series, it's actually a different type of data. So in any kind of time series, what we do is the year will be on the x-axis, or the quarter, or the month, or the day always will be on the right side. Now, it doesn't have to be on the right side, theoretically, but somehow it became the norm that the time will always be on the right side. And number of visitors. In this example, this is our variable. That's actually on the left side. And as you can see, this is the number of park visitors. So there's an increasing trend. So the number of park visitors keep increasing over time. So now we are done with the categorical data. We look at the numerical data and how we can draw numerical data. We can use frequency distributions and cumulative distributions to draw histograms and ogive. There's also stem and leaf display. We don't use that one that much, so I'll just cross that one. It's actually pretty old style. So we just need to know the histogram, how to draw a histogram, and we also need to know how to draw a cumulative histogram, which is ogive. So what's the frequency distribution? It's actually a table. You just look at the frequencies and you categorize data. Now, in numerical data, we don't have categories. So how do we do? That means we need to create categories. So in a numerical data, we create categories, and using those categories, we create a table. So how many categories are we going to use? There is no certain answer, and there are different formulas for this. Like for example, this is one formula here. It looks at the interval width, largest number minus smallest number, number of desired intervals. I use another formula. Let's say the number of intervals, like how many intervals that we want to create. Let's say we have this thing here, how to have a number of intervals. That should be equal to the square root of the sample size. So if you have like 10 observations, then maybe just create 3 is enough. Well, of course, that number might not be exactly the same. But if you have, let's say, 100 observations, you'll create 10 classes. That actually sounds reasonable. So here's an example of frequency distribution. We have the daily high temperature for 20 winter days. So that looks pretty high because the numbers are in Fahrenheit. And that's actually F. So if it is Fahrenheit, that means it's much lower in Celsius. But anyways, this is Fahrenheit. So you have 20 numbers. So what do? How many how can we draw a frequency distribution? First step is to sort the data in ascending order. So sort the data from smallest to largest. What is the range? It says the range is the maximum. Maximum is 58 minus minimum. Minimum is 12. The difference is 46. That gives us the range. Now, how many classes should we use? If you take the square root of 46, that will be about 6, 7. The course book suggests 5. That's also fine. Compute the interval width. That is actually something that you decide. If you make 5, then to cover 46, you will need an interval width of 10. And determine the intervals. And then this is what we get. How many numbers are between 10 up to 20? Let's see. 1, 2, 3. So you put the 3 here. And the 3. How many numbers are between 20 up to 30? 1, 2, 3, 4, 5, 6. How many numbers are between 30 up to 40? Now 30 is included, but 40 is not included. 1, 2, 3, 4, 5. From 30 to 40 we have 5. From 40 to 50 we have 1, 2, 3, 4. 40 to 50 we have 4, and 50 to 60 we have only 2. So this is a nice example of how to draw a frequency table. And if we divide the frequency by the total number of observations, in this case our total number of observations is 20. 3 over 20, that's equal to 0.15. So this will be the relative frequency. The relative frequency will be 0.15. And you can always multiply this number by 100. So if you multiply 0.15 by 100, you'll get a percentage of 15%. So a histogram is a graph of the data in a frequency distribution where you have the interval endpoints on the horizontal axis, and the vertical axis is either frequency, relative frequency, or the percentage. So same thing is basically from the same previous table. You already created categories based on the intervals, and we show the frequencies in those categories in this histogram. For example, from 10 to 20, we had 3 observations. From, say, between 10 to 20, we had 3 observations. From 20 to 30, we had 6 observations. From 30 to 40, we have 5. 40 to 50, we have 4. 50 to 60, we have 2. So basically, this is how you create a histogram. And in the histogram, it's the accepted practice. We have no gaps between the bars. So for the histogram, we have no gaps. For categorical data, bar charts, if you want, you can have gaps. If you don't want, you don't have gaps. But for numerical data in a histogram, we have no gaps. So histogram, the bars will be connected with each other. Now, one point is how many class intervals shall we use? If you use too many, you will have a graph like this, which doesn't look so nice. If you use too less, you will have a graph like that. Again, it doesn't make much sense. So the best idea is to use the formula that I suggested. Look at the sample size, and in the sample size, let's say n, take the square root of this sample size, and that should give you how many, like, optimal number of class intervals. So the optimal number of class intervals, this is what I recommend. Take the square root of n. Another thing is, now we know how to create a frequency table, and we also know how to convert it into percentage. We can do the same thing as cumulative frequency. Now, for cumulative frequency, we need to add the frequencies. So, for example, if you add, let's say, 3 and 6 together, the cumulative frequency will be 9. And to go to 14, what we do is, it is 3 plus 6 plus 5. So let's change the color, let's make it yellow. So if you look at all the numbers here, the total frequency, from 10 to 20 we have 3, from 20 to 30 we have 6, from 30 to 40 we have 5. So if you add them all, this is what we get, 40. And you can keep doing this. So you keep adding the numbers, and that will give you the cumulative frequency. At the end, the total number here should be the same as the total number here. And you can always convert them into cumulative percentage by dividing with the total. So that's called the cumulative frequency distribution. Now, if you draw the cumulative frequency distribution, this is called ogive. So ogive is the same thing as the cumulative frequency distribution. But instead of drawing, say, bars, you draw a line. So for example, this is based on cumulative percentage. So from, there's nothing less than 10, so you can start with 10 here. From 10 to 20, the cumulative percentage is 15, so this will be something like 15 here. Now, less than 30, the cumulative will be 45, so this should be 45 somewhere here. So this should be, make it red, maybe yellow. Okay, so this number is something about 15, and this number here should be like 45, and less than 40 is 70, so it should be something like 70 here, and less than 50 is 90, so this should be like 90 here, and obviously less than 60 will be 100. So this is a cumulative frequency graph, and the cumulative frequency graph is also called the ogive. Now the last thing for this course is a scattered graph. I think this is one of the most important things, because scattered graphs show us the relationship between two variables, two numerical variables. So we have the x-axis and we had the y-axis, and we see the relationship between those variables, and this is called the scatter diagram. And for example, this is an example about the SAT scores, the math and verbal scores by different states. So you want to see a relationship between the verbal score and the math score, and what you see is almost one-to-one relationship between these scores. So let's show this, just highlight this relationship. So there's almost like one-to-one relationship between these two. So what does that mean? You know, for example, many people say, oh, my math is bad, but my social skills are great, so I can communicate great verbally. Or some people say, oh, my math is great, but my verbal skills is low. Well, those are exceptions. So if you look at the data, what you see is there's almost one-to-one relationship between the verbal score and the math score. So this also means that someone good in language classes is most likely going to do well in the math course. And if you are good with math, then you will do good with other courses. And if you think about this course, statistics, now if you are good with social sciences, and if you are good with math, and if you are good with economics, and I'm sure you will be fine in this course. So we have some examples here, this class activity, and we will do this in the course. And we have another activity here. We will also do this in the course. And during the course, I expect active participation. So I will specifically mention names and ask them questions, and that will count in your class participation. So thank you, and see you in the next lecture.